Hi. So now we are going to be at the last lecture for this semester. Yay. I'm really very sorry because I can't use the normal PowerPoint slide right usual because there's some problem with my tablet. However, since this chapter is not that difficult, I hope you can get the essence for this chapter, and I'm sure that a large part of this chapter you have come across somewhere else before, right? Okay, so now the cross product. Okay, the result of the cross product is a vector which have a magnitude and direction. Unlike the dot product will produce you only with a scalar value which only have magnitude, no direction. But cross product will give you both the magnitude and direction. Okay, so the cross product is a little bit complicated, little bit, not too much, but I'm sure you can do it just fine. Okay, so now if you have A and B, okay, and the cross product of A and B is, how you do it is you segregate or make a section of all the X value and the I, or the Y value and the J, and or the K value and the Z. And then how to find, let's say how to find the cross product of I is how you do how you find the determinant. Okay, so it is AY times BZ minus AZ times BY. Then you get the answer for I. Okay, and then for J, how to do J? It is minus J dalam kurungan AX times BZ minus AX times BX. Okay, and then plus K, it is AX plus AX times BY minus AY times BX. I think this makes much more sense if we do it in an example. So yeah, this is what I say when this is not as clear cut as before lah. There's some problem with my tablet, which I don't know what. Okay, so now we want to find the cross product of A and B. Okay, first thing first, you have to do this structure lah, IJK. So what is I? I is minus 3 minus J 4 and K is 4, and the next vector is 1 5 minus 1. Okay, so now we want to find the value for I. So I is negative 2 times negative 1 minus 4 times 5. Okay, minus J, okay, negative 3 times negative 1 minus 4 times 1. Okay, and plus K. K is negative 3 times 5 minus negative 2 times 1. So the answer should be, for I, it is 2 minus 20. For J, minus J first, don't forget, it is minus J, like determinant. Okay, negative 3 times 4, and K plus K is negative 15 times 2. So the answer is negative 18I plus 7J minus 13K. Okay, so that is your answer, which can also be rewritten like this in a vector form. Negative 18, 7, negative 13. Okay, so that's all. So this answer example A. For example B, I want you to try to do this on your own. The answer should be 2 minus 7 and minus 6. Okay. Okay, so now let's move on to the next slides. Okay, so this is the properties of cross product. You can read this on your own. Okay, so now we are going to learn about, so for let's see here, where is example 4? So this is example 5 already. Yeah, I missed example 4. Sorry. So, example 4, what it mean is when, okay, let's do this here. What does it, how to know whether a vector, whether two vector is perpendicular or not, is the value of u, the vector of u times v is 0. So now we want to check whether this vector is perpendicular or not. Okay, let's do this together. This is so annoying. Okay, so now u and v must be 0 if the vector is orthogonal or perpendicular. So u times v in this case is 2 times 5 plus 2 times negative 4 plus negative 1 times with 2. So the answer is 10 minus 8 and minus 2, 0. So these two vector is perpendicular. Okay. Okay, so now this one we have. Okay, so now this is a equation of the line. I know it doesn't make much sense except when we try to do the example lah for this, right? Okay. Okay, so now we have here the point. Point is, what is the point for this example? Point is a static value. So static value here is 2 and minus 7. So P is 2 minus 7. And what is the n here? N. Okay. And here is the vector. Okay, remember P is always a static point and n is a vector, where our n here is 4i plus 3, 7. And to find the equation of the line is using this formula. So A. So our x here we don't know, and our x naught is our static point on the line, which is 2, plus b, and y minus our static point on the line is minus 7. Okay, do we know the value of a and b now? Yes, we know, because this is the vector. So our vector here is, our a here is 4 and our b here is 3. So include that into the formula. So this answers example 6. That's all. Okay. Okay, so now moving on to the next slides. Okay, equation of the line. Okay, where L1 is represented by this parametric equation. Okay, and the parameter T gives the position vector V of a point on L, on line L. Okay, so now I think the best thing for us right now is to do the example so it will become more clearer for me and for you, right? So what is the first example 7a wants us to find the vector equation and the parametric equation. Don't be intimidated by this term. It's really is a simple thing really. So now we know our point is the static point, which is 5, 1, 3, and our vector is 1, 4, and minus 2. Okay, we are now trying to solve example A first, right? Okay, so parametric equation, okay, is the point plus with the vector, and t, that's all. Okay, and y, 0.1 plus vector 4t, and z 3 minus 2t. So this is your parametric equation. That's all. Okay, and vector, how to do the vector equation? Okay, so for vector equation, it can be rewritten like this: 5 plus t equal to 1 plus 4t equal to 3 minus 2t. Okay, which can also be rewritten like this: 5 plus t I plus 1 plus 4t j plus 3 minus 2t k. So that's all. Okay, so now I'm going to erase some of this. So we're going to do example 7b. So 7b, our point is 1, 2, minus 3, and our vector is 4, 5, negative 7. And find the parametric equation. Okay, no biggie, it's really simple. So 1 plus 4t, and y is 2 plus 5t, z is negative 3 minus 7t. That's all. Okay, please take note this value because we're going to use this in our next slides. Okay. So in the equation of the lines, we can also find the symmetric equation. Okay, what does it mean here by symmetric equation? Is just let t to be at the left hand side of the equation. Okay, so here is what is parametric equation is all about, and now just let t to be at the left hand side. So now let's try to do this. Okay, so now what do we have here is 7b, right? So 7b is so for 7b is x minus 4 over 4 and equal to y minus 2 over 5 equal to z plus 3 minus 7. So that's all. That is what is symmetric equation all about. Okay. Okay. So that's it. That's all for this lecture.